This is a video to show you how to do destructive physical analysis of an 18650 cylindrical cell in a safe manner. And this video is produced by the Electrochemical Safety Research Institute at Underwriters Laboratories. The first thing to do with an 18650 or any type of lithium-ion cell that you want to destructively analyze is to take it down to 1 volt or below that in order to do the destructive analysis in a very safe manner. So once a cell is discharged, then you can check the voltage and make sure that it is below 1 volt, because lithium-ion cells do tend to have a voltage bounce back once you discharge them to even a low voltage. So confirm that you have at least discharged it down to 1 volt, and then you can start working on the cell. The method that we are showing here has been used for more than 25 years. And so we have been able to use this type of procedure to open up the cell in a safe manner. The tools that we will show you have also been used for a long time. And there are a few variations that you could do, and I will describe that also as we go along. So this is a sample cell that we are going to be using to show you how to open up the cell. The cell, as I mentioned, has been discharged down to 1 volt. And the first thing we will do is to remove the label. The green material that you're seeing that is being cut is actually the label on the cell. Caution should be used typically when cutting the label or removing the label. If you are just doing a destructive analysis of the cell, it is not a big problem, because even if you scratch the cell can, you're still going to be opening up the can, so it is okay. But if you want to use the cell without the label for other purposes, such as building a battery without the cell, the original label that came with the cell, or for other analysis type of work that involves a cell can, then you've got to be careful about making sure you do not scratch the cell can. The cell can material is steel, and so even a slight scratch can cause a lot of corrosion in the cell. So what you're seeing here is the insulation washer type material that was placed between the label and the cell header. If you look at the cell terminal, you actually have both the positive and the negative in the header area. The center part of the header area that you're seeing is the positive terminal. And the can itself, which is brought around the positive terminal and crimped crimped above the positive terminal, is the negative of the cell. So the can itself is negatively charged. So now what we are going to do is open up the can. So we have a Dremel-like tool. It's almost like a diamond cutter. And we are going to go around, place it around the header below the groove. And we are going to, actually, it goes around the groove. And you can go below the groove also. And you twist it around. So you start slowly making headway into breaking open the cell can. And it is a pretty fast process, because the header or the neck area, which is a groove, is easy to work with also. So we're almost done with breaking open the cell can there. So you can see that it's loosening out. And there are a few things that I would like to also note as we open up this header area. You see that orange, another washer-like thing that is placed on top of the electrode stack, between the electrode stack and the header. That is to provide insulation between the electrodes and the metal header. Another thing also that we will notice is that the tab from the positive electrode is attached to the underside of the header. And this is what this is the positive tab that connects the positive electrode in the electrode stack to the header, and this is what makes it the positive terminal. You'll also notice that the tab, the current collector tab, is covered with insulation tape again. That again helps to prevent any inadvertent contact of that tab as it is bent with the electrode stack, thus preventing any type of short circuit. The next thing we are going to do here is to cut using scissors. We cut the tab, thus separating the header from the rest of the cell can. So now we are going to continue with the destructive analysis. We take out the insulation tape first, and then we start cutting open the can with a metal cutter. There are many ways this can be done also. So you once you start peeling off the metal can from the electrode stack, you can either roll it up and like we are showing in this particular video, or another way to do it is to just use a Dremel tool and go all the way through the length of the metal can. So we go from the top to the bottom with the Dremel tool, scoring the metal can just enough for it to crack open, and then we can remove the can itself and separate it out from the electrode stack. Again, caution should be exercised while doing this, because if you cause any deformation of the electrode stack, since there is still wet electrolyte and the electrodes are all present along with the wet electrolyte, you can cause heat to build up due to internal short circuits that can occur due to the deformation or compression. So whether you're working with the Dremel tool and scoring the can, or whether you're using the metal cutter like we're doing here with the pliers to remove the metal can, either way, you just have to be very patient and go through this in a very slow manner to prevent heat buildup during the destructive analysis. And what you're seeing here that is being exposed is the copper current collector, which forms the anode of the cell. And you can see that the copper current collector is in touch or is in contact with the can itself, making the can negatively charged or negatively polarized. So this really requires a lot of patience, as I mentioned, because you're working with a smooth can and gloves, and it's not the grip is not very good. So you just have to be extremely careful in how you do this. So we're coming almost to the bottom of the can. So when you get to the bottom of the can, what you'll realize is the tab that is attached to the current collector, copper current collector, on one side is actually attached on the other side to the metal can itself on the bottom. And that is done by many different ways. Some of the methods of doing that is to use TIG welding. Sometimes ultrasonic welding is also used. And you also see that blue insulation material that is placed between the electrode stack and the metal can itself, with space for the tab to go and through the side and attach itself to the bottom of the can. So you can see again, there's some tape that protects the negative tab from touching any of the electrode materials inadvertently. And you can see that it is spot welded, or TIG welded, I should say, to the metal can itself. So now we are going to cut that tab also. And now we've separated the can from the electrode stack. That's the insulation tape that was placed between the electrode stack and the metal can. So now we are going to remove the tape that is holding the entire electrode stack together. There are tapes on both ends, and you can see that the tab is also well covered with some insulation tape. So now we are going to start looking at how to remove the tape. Again, you can see a lot of caution is being exercised while doing this, because you do not want to tear the copper current collector and damage the electrodes inside, because there are many reasons why you don't want to do that. For the first thing is to avoid any internal short circuiting that can result in heat and any type of a smoke or a fire. The second thing is also to preserve the materials that you're going to be observing, whether it be the current collector or the electrode itself. So the thing here is to find the start of the tape so we can remove it in a methodical manner. So the tape on the other side of the cell is also, the electrode stack is also being removed. So now that all the tape and other materials have been removed, the best thing is for you to keep a very clean surface before you open up the cells, especially if you're going to do analysis of the electrodes and the separator. Because if you have contaminants, then you're going to have some kind of variation in your analysis. So be very careful, have a very clean surface, and also be very careful when you open up the cell. So in this particular cell, you can see that the black material that is pasted onto the copper current collector is the anode active material. And that black material is, in this particular cell design, graphite with binder and active carbon and so on. It's made into a slurry. It's pasted onto the copper current collector, goes through calendering, drying process, and then rolled into its own roll. And then at the same time, you also see that there is a cathode that will be made. So this particular part that you're looking at right now is the separator. The interesting part about this separator is that the yellowish shade that you see is actually because of a coating that is present on this particular separator. You'll see that only one side of the separator has that yellowish tinge, which is because only one side of that separator is coated. And what we also learned is that the coated area, the coated side of the separator is actually facing the cathode. The uncoated side faces the anode. So the cathode is pasted onto an aluminum current collector, and the anode is pasted onto a copper current collector. So now exercise is being used in opening up the whole electrodes roll. And since this is a fresh cell that was discharged, you'll notice that, of course, you see a lot of delamination from the anode because it has dried out a little bit at the edges. But the cathode is, very fresh and doesn't have any gold color because all the lithium ion from, the anode does not have a gold color because all the lithium ions from the anode have been taken back to the cathode. When the cell is fully charged, then you'll see that the graphite or the anode is very golden color because of the presence of lithium ions in the anode. But because this is a discharged cell, you'll notice that the anode is black in color because it has given up all the lithium ions that have moved from the anode to the cathode again. Again, as we get to the center, you'll notice that there's a little bit more delamination because the roll is so tight. And what you're observing here is a central metal mandrel that has been used in the center of the cell to roll the electrodes over it. When we look at the very first few designs of lithium-ion cylindrical cells, we did not have a metal mandrel at all. There was actually just an air gap in the middle. And what manufacturers figured out as they started putting more and more materials into the cell and making it really tight is that if they had a very directed or a definite path in the center of the cell, then it actually helped to have escape of gases if there was a catastrophic event, and also help the current interrupt device to function as it should. What you're observing here is actually the separator that had been moved out first, and then the cathode electrode that has been placed at the very top. You'll notice that there is this gold color metal that is in between. It's actually the anode current collector that is covered with the Kapton tape, which gives it that gold color, because Kapton tape has that kind of goldish tinge to it. And what you also will observe is that the current collector for the cathode is actually in the center of that whole electrode roll. Whereas for the anode, we noticed that it was on one edge of the anode, which was the very last part of the anode roll itself. It's just showing you both sides of the electrodes. Again, you can see that one of the sides of the separator has this yellowish tinge, and the other side of the separator does not. And I just want to remind you that the the side with the slight yellowish tinge is actually the side that has the coating, ceramic coating on the separator, and that side faces the cathode. So to conclude, from these materials, you can actually take samples and do scanning electron microscopy, energy dispersive spectroscopy, and so on. And you can do this for both the cathode and the anode, as well as the separator. And so we are coming to the end of our video. Just want to say that I would like to reiterate again that extreme caution should be used while opening up the cells. Although your cell has been discharged below 1 volt, making it more safe, you still have liquid electrolyte inside the cell before the electrodes dry out. So you should not work too fast, or in a careless manner in order to prevent any type of short circuiting that may happen. If you have any questions, we have our email address that has been provided here. So please feel free to let us know if you have any questions that come up. Thank you.